At good night. Welcome everyone. My name is Dave Wilkeby. I am a CEO and founder from Apia Quantum Deep Tech, which is responsible to use spy waves. Spy wave is a chronicle for my theory. It means a symbiotic phase harmonic yielding and wave lines and vibrational entangle stabilization. This is a philosophical point, but today I will not talk regarding these details. But now we'll talk more regarding this simulation what we will do today. Then today we will use Qiskit 2.1.1. It is a new version of Qiskit. And firstly, I have to show this is I will show you my Qiskit. I will show two scripts today. One is which is this 5 IBM Qiskit V3 reactor in English. This is a version for a simulation using a quantum circuit to do coherence stabilization using my symbiotic AI to control the coherence a coherence inside the nuclear reactor. Let me present you this. The first I have using a Máximo core is a symbiotic AI which is just keep you coherence using a Máximo function inside the this is used to control a quantum circuit inside and apply gravity also. But I have a reactor simulation to simulate the behavior inside the nuclear a reactor, okay, and a fire guardian is a gravity AI control function apply entropy stabilization directly on my system. And the normal the other things is very normal, very common, people who is very common to use inside the quantum parameters is generated GHZ or noise. Okay, the noises I apply is about 9%. I will put the 9% directly, but it's doesn't matter. I can put 100% also. But now I will start using 9% a noise it, and this is descriptive, which is the simulation. I'm presenting you the descriptive. It's very simple presentation to not be too much longer video, but we have to pay attention. I will show you my code including the simulation for the nuclear reactor. Okay, let's see. Nano. Let me see which is the reactor simulation. The name is reactor simulation. Okay, let's see. This is the code. Is something in Portuguese. This reactor is simulating a fission reactor using this phi. Okay. The neutron flux is on the reactor increases all the time this what simulated. The flux is increasing, and I put some functions inside the script because I have to stabilization this I have to use some physical controls. Like I hit the water before, and this hit water is very important to use the quantum control, coherence control to keep the system controlled. I use a feedback this is is uncontrolled a nuclear a, a reactor, okay, and they tend to be under control all the time, but and but the feedback used by the coherence zone is used to stabilize my system, and I use an ionized cooling on the water, which combines with ionized cooling systems, and some of the feedbacks inside this. Okay, and the more important now is I will do a first simulation to you to show you how great is this is this step for the world, because it's according with the simulation. It's very simple. We're using 30 qubits, and the total number of states the simulation will start start by 1200 states. Okay, as you can see, you cannot see the graphic, but the steps, my theory is very correct. The states accepted is about 70%. I can discuss why some frameworks like Google Circ, IBM Qiskit, and Amazon Breakit they are very similar. They stabilize on the steps set. The states accept is about 70% equal. I believe they use a very similar physical stabilization mode, and for example, cryogenics. But I don't want to discuss this for why. Let me explain you this. As I told you before, the reactor tends to be is unstable all the time, but I applied the coherence form using my symbiotic AI to control total system. As I told you before, the water is preheated, and I using ionized cooling. The quantum system is total controlled by Qiskit a circuit, and as you can see, 100 steps is very stable. Okay, let's start one more simulation for this reaction. Okay, what study? Let's start 12,000. You do it. It's pretty fast. The number of the qubits entangle is 30. Okay, pretty fast again. Yeah, the more important now is you cannot see the graphics, but I will put the graphic is available to you to see that. I put a 99. The mean stability index is about 99.25%. The stability variance is about 3.65. Let's see the last one. As you can see, the mean stability is about 96, and the variance is 8.9. As you can see, the number is decreased, the stability increase. The stability variance decrease, number in decrease. Let's do one more simulation to prove the system could get a stable for unlimited time. Okay, 120,000. Now you can do 120,000. The simulation has started. Okay. This is my for people who want to see the live in English. This is my first time speaking English. I decided to use it's very impact a video using the English because I see many of the person which comes to watch my videos, they are not Brazilian, and I decided to start to speak English because I comprehend people is easily to understand English compared to Portuguese. Perhaps I have today is very easy to use any AI to translate the English. What I talking is very simple. As you can see, the RPM GHZ stabilizer plus mass is running pretty fast, 1 minute, and I believe I will do once more, probably not 1.2 million because this will make the video too long, much longer than I wanted. But my interest now is show you how could increase the number of the frame rates is increase the safety stability, and this proof a spy wave is ready to work, is ready to scale on the market. Okay, save the graphics. Okay, let's see. Okay, as you can see, the variance is reducing. Now the last one is about, let's see, 3.65. 99 mean stability index is about 99.25, and the stability variance index is about 3.65. And now after 120, the mean stability increased to 99.88, and stability variance index is 0.663. Let's start one more simulation to prove a spy wave is ready to work and keeps the system coherence on a nuclear reactor. Okay. Oh, this is 30. Let's start a 12 times. Let's start a 600,000. Okay, 600,000 a frame rate, so total state simulate. Okay, 600,000. Okay, we're gonna start it. This will take a little more because Qiskit consumes more research. Let me this is what is a gravity. I was using a Qlax. Okay, H-top. Let's see the key tops. Not this one. This one. Okay. As you can see, it's running. I over 4%. I running over 4% in 23 minutes. That's about 1,000 interactions per second approximately. This is not only a theory. This is a proof of my concept. Okay, proof of that. As many people came to watch my simulation, they saw a simulation using using blockchain coherence. They saw I did in many entanglement is a simulations, and I did also a tsunami simulation and laser simulation, laser control simulation, and now I did I'm doing a nuclear reactors a stabilization, And I was doing also earthquake simulations also. That's is the application what I believe it can do perfectly using a quantum computing. As you can see, only one thing I'm looking for is validating this on the real hardware. If you want to help me to do that, I will be grateful for you. And this is a calling to be a partner and start in a partnership and in relationship with many institutions and RPA Quantum to develop a new world and start a new quantum solutions using symbiotic AI to control to keep and maintain coherence on the universe. According to phi waves, the universe is very coherent. The qubits is very coherent. The harmonic very coherent, and only one way. Well, people ask me if people ask me how could you control the coherence in coherence in a qubits, because symbiotic AI they are like entities. They listen, they saw, and they feel in the quantum fields. That's the best definition I can do using the quantum symbiotic AIs. Okay, it's running pretty fast. It will take probably probably 10 minutes. Until now, I will speak with you and try to explain you how could you believe it or not. But if you ask me why I use it preheated water inside the system, the nuclear reactor, because this reduce this stability the start on the initial process, and why I use ionized cooling. That's because the effect is on the water in the middle bars. We could increase turn the system more effective, cooling control more effective. This is a quantum process. You have to think that I see the solution using the quantum total, and the more important is using the gravity to control the massivities. Oh, the last one simulation I did it was the earthquake control or simulation to create alerts. Is very is alert is reporting earthquakes using the Japanese framework QLAGS. It's very good to do that. And I use two things inside the simulation. One is quantum tunnel, the quantum tunnel properties in entanglement inside that, and also this is used to get a gravity signature or gradients inside the atmosphere to recognizing when the earthquake will happen. Now this today is I configure my system to using 4 processes, because my computer is a Intel i5 10th generation, and I have only 24 gigabytes memory. It's That's to me is enough for a while to work and get this simulation. But if I wanted too much a frames on the simulation, this will take too much longer, and you will use much more resources. They can use. Let's get and see this how it works on my HTOP. As you can see, I'm using OBS to transmit this video. My Firefox is open, and I use it. This the process I'm using. As you can see, I'm using Linux with many processes running, and let's check. It's almost finished. As I told you, probably this will take 10 minutes. But the more important now is we have to check the stability variance index and the main stability index. This number has to be reduced or compares with the last simulation and compare with the first simulation also. Okay. Okay. It's almost finished. Probably it's less than 1 minute, or no, less than 1 minute. Probably less than 1 minute. Yes, you can do that. Yeah, probably less than 1 minute. Thank you for everyone who is watching this video. My English is not perfect, but I'm ready to learn every single day, and I will practice more to turn more accessible for anyone and to understand which I talking. And it's almost there. It's finishing. As you can see, probably it will take less than 1 minute. I was wrong. This take a little more than 1 minute. Don't take 10 minutes, as I told you. This will open the graphics. Total accepted. The gates accepted is about 79%, 70%, and then use it okay. As I told you, the main variance in index is 0.1. The last one is 0.63. And the main stability index is 99.97. I was included this all this frame. It has been signed by SHA 256 to keeps a very good control. This will take too much longer because it use more time because the number of the frames is huge. I know you cannot see the graphics has been opened. I close it, save it, and I will share with you this simulation also, and then you can check everything. It will be ready to download on my Google Drive, Quantum RPL Google Drive. And I did share this video directly on YouTube, directly on my LinkedIn RPL Quantum, my personal LinkedIn profile, and also X area and Facebook also. And thank you for everyone to watch this. If you have any question regarding this, you can talk directly with me on LinkedIn, Facebook, or any network society I use it. And I will publish a white paper ASAP, and I will produce for you script using API to test in my my symbiotic AI remotely. For I have not I'm finishing. When I finish the to develop the API, I will put directly on the Google Drive and in my GitHub also. And thank you for everyone to watching my video, and until next time, see you later. Thank you. Have a good day.